Good afternoon, everyone. This is Mr. Guma MT from Fezile Dabi. Today I'm doing the Theorem of Pythagoras for grade 8. Now, before we do the Theorem of Pythagoras, I want you to understand that term there. The first part, the theorem. What is a theorem? Now, a theorem is defined as a rule, principle, or a statement that can be proved to be true. Now, in mathematics, if we give you a rule or a principle or any statement that you can prove to be true, you must know that you are actually dealing with the theorem. Now, moving on. Now, the theorem is a statement that can be proved to be true. Now, let's deal with the theorem of Pythagoras. What does this theorem tells us? The theorem of Pythagoras states that in a right-angled triangle, folks, be careful, only in a right-angled triangle, not any other triangle, the square of the hypotenuse is equals to the sum of the squares of the other two sides. I will explain this thoroughly later on. Now, let us look at the theorem of Pythagoras in a diagram. Now, in a diagram, let me start with the hypotenuse first. The hypotenuse is that side which is opposite the 90 degrees angle. Remember that. When we refer to the hypotenuse, we are talking to the side which is opposite the 90 degrees angle. Now, the theorem says the square of the hypotenuse, that is equal to the sum of the squares of the other two sides. Now, meaning that in that square, all those small squares must actually be equal to these squares plus those squares. Let us quickly count the small squares here. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Now, if this theorem is correct, these squares plus these ones must actually give us 25. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That means the theorem is spot on because the square of that side is actually equal to the sum of the squares of this side. Now, be careful. Do you see that I have got 5? Now, the 5 is the length of that side. Let's go to the diagram and look at the length. The length is actually measured from here to there. In this case, it would be 1, 2, 3, 4, 5. Be careful about that. The 4 is the length of this side. In this case, it would be 1, 2, 3, 4 when we measure it. The 3 is the length of this side, which is 1, 2, 3. Be very careful about that. Now, the theorem in a mathematical form states that b squared, which is the hypotenuse, you see there I have put small b to measure that side. Small b squared is equal to small a squared plus small c squared. Small a squared is there plus small c squared, meaning that I must square the length of this side and equate it to the sum of the lengths of those two sides, each one of them squared. And there I have got my reason. It is the theorem of Pythagoras. I took it from the theorem of Pythagoras. Let's move on. Now, moving on, I'm still in a theorem of Pythagoras in a diagram form. I want you, my friends, to understand this. Let's look at this one. The length of that side, which is small b, and the triangle is triangle ABC, now labeled, is 1, 2, 3, 4. The length of the hypotenuse, which is opposite the 90 degrees angle, is 1, 2, 3, 4, 5. The length of this side, which is small c, is 1, 2, 3. Now remember what the theorem says. Those small squares together must be equal to the sum of those small squares here and there. Let's count them here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's a 5 by 5. It's a square, which is 25. Now let's count the squares here. 1, 2, 3, 4. 1, 2, 3, 4. It's a 4 by 4, which is 16 squares here. Here it is 1, 2, 3, 1, 2, 3. It's a 3 by 3, which is 9 squares. And 16 plus 9 is actually equals to 25. Again, the theorem is actually spot on. Now be careful. The labels are now different. That side is labeled as a small c, but it is the hypotenuse. And this one is small a and that one is small b. Now in this case, small c squared, which is the hypotenuse, is equals to small a squared plus small b squared. And there's the reason again. Remember, you must always provide the reason when you apply this theorem. Moving on. Now, the theorem of Pythagoras in calculations, be very careful with this one because we are expecting you to be able to do calculations. You are given a right-angled triangle. Remember, we said the theorem of Pythagoras only applies in a right-angled triangle on the right. Let's look at that right-angled triangle there. Calculate the length of the unknown side. Now, which side is unknown? The length of that one is 3. The length of this one is 4. We don't know the hypotenuse. Now, that means we have to calculate the length of this side. How do we do that? 1, because it is a right-angled triangle, one of the angles is 90 degrees. I am going to be using the theorem of Pythagoras. The hypotenuse squared is equal to the sum of the squares of the other two sides. Now, I substitute. There's your 4 there. 4 squared plus a 3 squared, which is equal to the unknown side. Simplifying. 4 squared is 16, 3 squared is 9. Moving on, 16 plus 9 is 25. Now, b squared is 25. I'm not looking for b squared, I'm looking for b. That is why I'm going to take the square root of both sides. The square root of b squared is a b. The square root of 25 is a 5. That means b is equal to 5 units. And b is that side there. I hope you are with me, folks. Very important, right-angled triangle. We apply the theorem of Pythagoras. And we did that. We got the answer. Moving on. We are given another right-angled triangle. There's your 90 degrees angle. What do they want here? Given a right-angled triangle ABC. Now, different from the first triangle, this one is labeled ABC. Calculate the length of AC. Now, AB is 6 units, BC is 8 units. We want to know AC. Because it is a right-angled triangle, again, we apply the theorem of Pythagoras. B squared is equal to 8 squared plus 6 squared. I have substituted those two lengths there. Now simplifying, 8 squared is 64 and 6 squared is 36. I add them together and I get 100. Now remember, b squared is equal to 100 and I'm looking for b, not b squared. And now I have to take the square roots of both sides. The square root of b squared is b, the square root of 100 is 10. That means b is equal to 10 units. Now remember, they said we must calculate the length of AC. Therefore, I must answer the question. AC is equal to 10 units. That means from here to there, it would be 10 units. Moving on. Now, we are doing Pythagoras in calculations again. Look at this one now. What is the difference here? They gave us the hypotenuse. We are no longer calculating the hypotenuse, and they gave us this side. They want us to calculate this side. Be careful about that. Now, moving on. B squared is equal to A squared plus C squared, theorem of Pythagoras. But why? Because that is a 90 degrees. That means the triangle is a right-angled triangle. We substitute. Before substituting now, remember we are looking for this side. We are no longer looking for B squared, which is that side. Now I have to manipulate this equation. Now I took small a squared into that side, and it became negative small a squared. And this side, I'm left with only small c squared. Now I can substitute. Small b squared is 15. There's the hypotenuse, 15. 15 squared, and small a squared is 12 squared. 15 squared is 225. 12 squared is 144. Now it is 225 minus 144, which is 81. But now I'm not looking for c squared, but I'm looking for c. I would take the square root of both sides. Now the square root of c squared is c, and the square root of 81 is 9. Sorry about that, it is supposed to be c from there. Now we answer the question. That means QR is equal to 9 units, folks. That is the theorem of Pythagoras being applied now when we are not looking for the hypotenuse. Now, lastly, there's your QR code for practicing. I have got some beautiful questions for you there to practice. If you want to use the link to access the practice questions, it is fine. You can use the link. Remember, practice in mathematics makes perfect. I'll give you some few seconds to scan that particular QR code so that you can answer, or to take down the link so that you can answer the questions. All the best with the theorem of Pythagoras. Thank you very much. Bye-bye.